very much. That was I'm sure there are a bunch of questions that will coming now that this is over. I think as I speak, the poll should be going up just so we can get a sense of who's here, how did you hear about us? If you can take some time to fill that out, that would be very beneficial. But for the first question that we typically throw out to everyone that we have the honor of being a guest here. So with everything you said, what is computational design to you? What does that mean?
That's a big question. I think really, I would of course need to spend quite some time thinking about this. That's just my nature. But I think my answer today, there is a distinction, between computational design and kind of this mentality of big P parametricism that I think we're beginning to, as a practice in an industry, draw and separate a bit more. I think computational design, in a nutshell, if I could, describe it, to my grandmother, would be something like using a computer in the process of design for the things that a computer is good at. And then, if the question is why, it's because then therefore it's not to save time, but it's because then I can do things that a human is good at while the computer is doing that.
All right. So essentially, it's not like you said, it's not about time saving. It's the right tool to be used. The right system to do what needs to be done. So if the computer is good at this, let the computer do it. As a human being, I'm great at other things. So nicely said. But with your background in biology, you talked about with this imaging thing that analog, digital. What drew you to computational design? How did you transition really from that background in biology to being an architect and then now leading the computational design studio? What influenced those decisions?
Yeah, that's a really good question. And I think there's a lot of nuance to that that I'm reading that may not be apparent on the surface. I'm gonna try to give it some credence in my answer. I'm gonna divulge my age a bit here, but my first foray into coding was learning the basic language in the 6th grade and learning to make some graphic visuals using BASIC to write code, and then moving on to DOS prompt and kind of working at that level. That was always interesting to me, and I think the idea of automating any type of a task was really compelling to me. That it's not making a thing, but it's making instructions for the computer to make a thing. And there was kind of this design by proxy that was super interesting. And I think I found that return with the help of a really great drawing teacher while I was studying biology that encouraged me to practice drawing with my weak hand, with my left hand. And I had a really strange, similar feeling of drawing by proxy. It was my hand, but it felt like a disconnect. And so that's always been kind of like a personal, just feeling thing to me, like this making instructions to actually make the thing. How did that lead to a computational design studio? Some of the factors that go into that, there was a group of us several years ago, just before we created LINE, and we did a lot of competition work, outside office hours, and stayed up all night and kind of entered these things, Evolo skyscraper type things. People that are young and don't yet have children can participate in, and we had a little bit of success, and there's a little recognition, and so we got some encouragement, I think, from the office, and they started to agree to allow us to spend 4 hours on a Friday afternoon, so that we could at least get some time in the office working together. And that was about the time, 2010, 2011, somewhere in there, we started to see, Grasshopper come into play and people start to dabble. We were picking up some parametric design. And that was a huge potential that I think some of us could see, but it was a really small group. And, quite honestly, it seemed like a missed opportunity for people that were really into this. And it was something that was so nascent at the time that there wasn't a clear direction for how it could influence office work. It seemed like a missed opportunity to not try to find a direction to put that to use. And so creating a studio that could leverage parametric design, computational design, really became a way to find an opportunity for that kind of curiosity and skill set and expertise. But then there's always, kind of confluence, and I rarely make any decision based on kind of one thing. And so that was kind of the genesis, you might say the why, but there's other compelling reasons. And the startup costs of putting together a computational design group were virtually zero, because that was just investing in ourselves to learn to use the software, to how to apply to make methodologies and workflows. It wasn't like equipping a shop or buying machinery and equipment. And so the startup cost was low. Therefore, the ask, wasn't quite as daunting to approach the CEO to say, can we do this? Because there wasn't a lot of investment other than our time going into it. So I think that's one thing that's kind of maintained its relevance even now. Anyone that's looking to have an impact and get to the table early, we all are still afforded in a mostly free ecosystem of software. If you're looking at Rhino and Grasshopper, ways that we can improve our skill set and our experience, and all it takes is making the time to do it.
So speaking of that investment cost being just the time for you guys to learn the software and show what you can do with it. Not very. How did you account for that? Was that time outside the office or in the office? And
that wasn't initially. That was a personal investment. And that was something that again, credit to our small team that has kind of grown and expanded and waned through the years, but there's a lot of personal investment in that, kind of ongoing education. The model that we, that eventually moved to within the studio is something that affords us a percentage of our time that is put towards R&D, and a percentage of our time that is toward project billable utilization. And so, some negotiation and some thinking through that to kind of find the right mix. And, I think that's not something that's isolated within HKS. I think other companies have groups with similar models, but, finding a business case and a way to kind of support and validate that is necessary as we begin to scale up.
That's a good point. Something that stuck out to me and maybe some other people is how you categorized architecture as being in that assembly line, was still in that stage, not necessarily this fourth industrial AI or not. Am I guessing that's because you're viewing architecture as a holistic thing? The idea of designing isn't separate from making. Because there's arguments to be made for, hey, there are architecture firms, design firms that are cutting edge, and why would you put us in two? Yeah,
I think you explained it the way that I'm kind of looking at it as a provocation, of course. Certainly there are studios and teams that have a high degree of technological proficiency in computation, fabrication, materials exploration, and these type of kind of vanguard offices or studios, could be clearly positioned, you know, in this this kind of fourth industrial revolution, you know, to say. But when you do take into account the industry as a whole and the understanding that, you know, many people have kind of described it, you know, as paper architecture or built architecture, and I never really appreciated that distinction, because I think that it discounts the importance of the unbuilt or the theoretical. However, I do appreciate that design is, in my opinion, maybe more impactful when we consider the eventual linkage to the delivery, fabrication, construction, you know, the methods that we're going to use. And I think, you know, an analogy with that might be to, you know, to take a look at, you know, some of the wonderful industrial design that we've all, you know, seen and ogled, you know, during our careers or going through school, you know, ranging from furniture to, you know, to technology items today. You know, some of the phones that we're using and wearables are absolutely beautiful, you know, in terms of the way that they're constructed, how they feel, you know, the way that we interact with the user interface. And those wouldn't be possible without considering the limitations and the opportunities of the shop floor, right? You know, it's almost every iteration, you know, whether it's Google Pixel or Samsung or Apple, you know, choose your flavor. Design is pushing capabilities on the fabrication front, right? You know, in small niches, and I think that's, you know, that's an obligation that we have, you know, as a profession, is continuing to kind of find ways to be at the forefront of that. And the industry as a whole, you know, there's a lot of needs of architecture, a lot of clients, a lot of programs, and a lot of times that things like robotic fabrication may not be immediately applicable, right? Or delivering a project that may not, you know, be an immediate value seen and saying, well, we can go completely digital with it. And so, you know, working in that way, you know, I would encourage, you know, us all to, you know, to be mindful that it's not a one size fits all. But when we look, like you said, at the industry at large, when we compare ourselves, you know, to kind of adjacent industry, there's certainly some things there that I think we could stand to catch up on.
Yeah. And with that view of, you know, just the industry designing and making, a question coming in here from Jordan is, how was the client involved with shaping the initial strategies? This is with SoFi, and how did that involvement help shape the outcome at the end?
That's a very astute question, you know, to ask with a complex project like this. Try to describe it in a way that that I can distill it into a good answer with this. So, you know, first and foremost, our studio, the way I worked and our studio worked wasn't a direct interaction with the client team, because we were working as a consultant within a larger team. So, you know, the primary lead architects had that relationship, and that was moving forward as it was. I think from my perspective, what I could share with this is that the client and their team, through the selection of you know, the contractor and the being agreeable to a design assist relationship with the fabricator, you know, so by the selection of the team and the contractor agreeing to this design assist relationship, that enabled that type of kind of interrogation and development along the way that really paved the way for this to happen. And it kind of goes back to what I was saying. It's about trust and it's about that relationship. But a design assist, you know, contractual agreement between a fabricator and the owner and the team is the legal means for that relationship to happen during the project.
That makes sense because you said true digital delivery. One of the most important things is trust, and I was thinking like every relationship, trust isn't built overnight, right? So what it's almost like this crazy risk that you just have to, or is there something you present prior for that trust to be earned? So in this case, like what would you say, was that prior?
Yeah, this one, I think it's a combination of this. It's a reminder, to me personally, and I think something that I try to keep in mind that, every interaction, that we have with someone that we're working with is part of this relationship. And if we're going to nurture that relationship, um, there's a good chance that we're going to work with that person again. The industry is not that big when you really think about it. And so, there were, prior relationships, from other projects, from other, research endeavors, between some of the entities and others, we were kind of working together for the first time, especially personally, people on the team, they have not worked together, but it's an acceptance that working in that manner, it wasn't an increase in risk. I think when you look at it that way. Now, some people may say, well, why would you take on the risk of delivering something in a digital standpoint? But we think and imagine in 3 dimensions, right? As designers and architects, and anymore these days, most of our development or conceptualizing of that idea is done in 3 dimensions, on a computer. And it's always seemed bizarre that at some point we take that and we flatten it out into 2 dimensions and we hand it across the table for someone else to reimagine and comprehend or interpret back into 3 dimensions, to go build it in 3 dimensions. And so making the conscious decision to say, if we can work with what we were calling a model of record, a single source of truth type entity, that's not something that's placing an enormous amount of risk on any one of us if we all agree that that is the single source of truth, and we're all working toward the same ends. So that's where that relationship, that trust comes from, is because I know we have to know what's in that model. And we know that what's in that model is what it is. It's not our intent, it's the design. And the recipient, then therefore, they have the assurance that that model is what it is. And that trust is built upon all of us taking accountability for our part in it, right? So, when we have a mistake and, everything didn't go perfectly, there were, hiccups along the way. But when you discover something in the model that's not what it should be, you have to be accountable for that. There it is, we acknowledge it, we fix it, we get things back on track. And I think that helps to build that trust is when all of us are working and being accountable for that partnership.
Yeah. Another question coming in here was the digital delivery method used for the whole project, but just for the skin system?
We did not use it for the whole project, but we used it for more than just the skin system. So there were some concourse elements, some other areas within the bowl, the concessions that we did use the digital delivery model. And that's a really good question, because I think that kind of ties into this idea that it's not a one size fits all. And we have all been in conversations probably where we're talking about delivery of a model, and there is a misinterpretation, that this means just turning over the Revit model at the end instead of creating documents. And I think even those of us who have the best internal standards, the Revit models that we're creating, in most instances are created to make drawings, right? And so they're not always created to be built from the model. And that's never, the way that, that we were trying to work with this. It was finding specific instances where we could find, value in delivering it in a digital standpoint. And so, whether it was, because of the geometry or maybe the complexity of the trades and the way things were coming together, there were a few instances that it made sense to take that piece and deliver that in a digital manner.
Yeah. So I know the scope for HKS was like the skin, but was there any part that wasn't your scope that you have actually applied this delivery system to, or was all HKS scope?
I'm not aware of, and I will say this with a big asterisk, that it could be the case that I'm not aware of it, but I'm not aware of others on the team using the delivery methodology and software that created to deliver scope, say for consultants, part of the work.
Yeah.
I think it was only architectural scope that we used it for, but that has me curious, and I need to confirm that internally. But I think that's the interesting thing with Concert now, is that the idea is that it is available, and there's not a limitation, from an architectural perspective. And I think there is a lot of opportunity when you start to think about how we can begin to work on a platform like that, with the different disciplines and the fabricators. So.
Yeah. So technical questions on the panels. What's the material and thickness, and how did you address thermal expansion?
I can't recall the thickness offhand. I think I may have it on one of those slides. So the aluminum, the material is an aluminum, and it has a special anodized color that was invented just for the project. It wasn't something that was used before. The thickness, I don't know offhand. I'm sorry. Thermal expansion, there was accounting for that between the primary structure, the space frame, and then each of the individual nodes. And if you kind of go back and look at some of that imagery, you can see at the scale of this, there is tolerance between the panel system, built into the way that it was designed to work together, that accounts for all of the expansion that we would be seeing. And so that was something that was taken into account, particularly in the way that the panels met at the node conditions.
I've been itching to get to the software. It's amazing how this project allowed to rethink sealing, validating 3D elements as being acceptable for AHGs. But how, when they receive the AHGs, for example, when they receive like a file and they use your software to open it up, what do they see? And how do they see contextual information relative to what they need, or how does that work?
I'm realizing now I should have included a slide on the software that we used at the time. I could probably find it. I don't want to unduly hold this up, but maybe I'll look while I'm kind of talking through it. Essentially, it's it was very functional minded software. We were thinking about the interface being something that could be kind of immediately understood and something that would work without a hiccup, more so than trying to design it for widespread use. And so it was less of a beauty thing and more of a function thing. But essentially, open up and there would be a window that would contain the architect's seal and stamp on one side, information that you would generally find on like the title of a drawing set, including all the information of the project, and then a panel that would include all of the assets that were bundled into that distribution, which would simply be a list of the digital file names of those assets. And it could be, those distributions often would include a Rhino model, several text files, or folders of text files. Could include PDFs, other types of models as well. I'll see if I can take a look and maybe just kind of show that and share it on the screen, because it's very basic. And when you click validate, you can see like a visual, everything would turn green. There's a seal. And if you were to try to manipulate a file and revalidate and you click it again, that one would turn red, and you would know that that's not the file that I was intended to receive. Sorry that I have to describe that rather than have a visual for it, but I'll see if I can find something.
Yeah, if you find it, yeah, it would be great to just have some people. Someone is asking, is there a plan to release source code for Concert as open source to speed adoption?
Not to my knowledge. The Concert platform is so this is live. You can visit online if you search up Concert VDC. You can go, and right now, I believe anybody should be able to sign up on the system and give it a demo, give it a whirl. But the idea is that they will be hosting and providing the service. And so rather than it being an open source platform, it's something that it may be not immediately apparent, but there's a lot of work going into putting together a service that can host the magnitude of files and file sizes, and be able to provide that blockchain validation that we're looking for. So this is something that I think it's the right move. I think there's a need in the industry, and I think rather than this being an open source thing, it's a service, and the financial model, it's there that you can kind of see how it works per transaction and the way it's offered. But anyone working at a firm that's interested in using it, I would encourage you to take a look, or to request some information, because it is something that I think is going to continue to benefit from having the opinions of others around the capabilities, the functionality. And that's certainly something that I know that the Concert team is interested in, is gathering some of that user input.
And so is that an HKS startup, or you're just licensing that to a different organization?
It's a different organization. We're simply licensing our IP. Yeah.
Okay. I was gonna ask, like, what the reason behind that approach was, because at our last Cody event, or one of the events we had, we discussed like the role of software development with design teams. We heard from like 3 people, one talking about or advocating for architects as computational designers who leverage visual scripting to build just custom solutions, right? The second had an in-house dev team, and the third was, it's like a startup. So do a startup outside of an architecture firm, that's all, they provide one service. So do you think one approach is better than the other, or like, what's your take on that?
Yeah, it's, this has been a conversation that we've been having internally, and I know one that's kind of happening across different firms at the moment. I don't have a strong opinion about there being a preferred method, and like you mentioned, there's success stories, looking at it from different perspectives. I can relay that it can become incredibly difficult to maintain software that's developed in-house, throughout the longevity and the lifespan. So we have Tim Logan on our team, for instance, developed a plugin called Elk that's it's part of the Grasshopper ecosystem. And that alone takes some updating time. Anytime there's new versions, and making sure that it's always playing nice with any new additional plugins or updates to Rhino or Grasshopper itself. We have done a few things of developing in-house, and I think those have been successful. There's other things that I think probably could benefit from having an outside team, that's really dedicated to putting that together. And when we discussed, I think this makes sense to us, with something as large as like an industry-wide platform, like what Concert is doing. They are very capable, in terms of the way that they have set themselves up and their leadership to kind of push this forward. Whereas that would be something that would be more difficult for us to try to recreate in-house. I did find the
nice.
the app. If you want to take a quick look, I think this is just a really short, just a really short video that kind of shows how it works. I can share that really quick if you like. All right. Can I get a verbal? Can you guys see my screen?
Yeah.
Cool. All right. So this is the side that we put our work into. And so this is going at like hyper speed, but see, I'm just I'm loading things in, putting the files in there. I'm going to pause it right here. So when the recipient gets it, they saw this was what we used during SoFi. And so they would have this list of these text files over here, that were corresponding to these different panels. There's also a Rhino model up here at the top, it looks like, but within this package, they could then highlight what they want to check. And when they load the issues and check these, you can see the hash, the hash that was applied to each of these will show the issue file and then the local file. And so if these are good, they'll highlight in green, and you would see that the architect's seal is still apparent over here. If they opened a file and manipulated it and saved it back and then tried to hash it and check it, boom, that turns red. Yeah. The seal disappears and it's no longer a valid instrument of service. And so that's the really quick kind of hyper speed version of how that works.
Yeah. That's really neat. In fact, going back to just staying on the project, when designing the panels, did you coordinate your design and script with consultants? And how did they use Grasshopper?
Mm-hmm. Yeah, so early on, working with the conceptual design surface, there were Grasshopper scripts shared, between HKS and Walter P. Moore. So that, as you can imagine, we're trying to develop structure and a design surface, and trying to mate those, get the curvature, get everything, associated with the right dependencies. And then, with the design assist relationship with Zaner and Crown Core, there were models, Grasshopper scripts, and eventually, we sorted the system that we could deliver with Zaner, these comma separated value files that they could then take, and with very minimal processing, they could recreate a model to visually look at, but they could also push that into G code to run their machinery. So, it was something that it wasn't a direct, our text files drove the machines, but it was very close to that type of linear workflow there. But yeah, we did, and we even dabbled. There was I'm trying to think of the name of it, but there was an application that we were testing, and I think Tim may have even written his own way to try to share live Grasshopper scripts between the teams at the time, where we could have multiple people working at the same time. But we definitely shared both models, scripts, and text files as part of the process.
Ernesto's asking, any lessons learned after hitting send on the files necessary for fabrication? Precise as technology tools are, we're only human, and there's still is room for an error or unforeseen condition.
Yeah, thank you for asking that question. And I'm not, I'm going to answer this in a way that I think we can have good conversation around it without being super specific about like a particular lesson, right? I think overall, what this reinforced is that quality assurance, practices, many firms, have had the benefit of decades, and in some instances, of course, many years, and establishing, kind of their internal processes for quality assurance in terms of, check sets, opportunities when you're going to have the right people in the team, page turn and looking at everything. Working in this manner, when everything is in a model, I think the lesson that I've learned is that we can always improve upon our quality assurance in the way that we internally review documentation in 3 dimensions, and so it's, if I kind of position this back into kind of how we, kind of teased some of the information out earlier in the presentation. If it's a question, it's like, how can we have the digital equivalent of a page turn? And, one of those things that, that I'm thinking about as I'm on site walking is, what if we all jumped into the model at like our scale and like, whether it's, a VR experience or whatnot, but just walked as a group and spent the hour walking the perimeter and looking at these things, maybe we could see some misalignments or some things that, eventually come out in the visual mock-ups, right? But the earlier you can spot those in the digital model, the better. So that's the big thing. I think the lesson there is that if we're not printing to paper, can the people that are really good at the quality assurance part and seeing these things, and can the full team, you can spin a model really quickly, but it's hard to zero in on, panel number 22,488 out of 35,000, unless you're walking at a human pace and looking at each of them. So that's the thing. I think quality assurance in a pure digital format is something that we can improve as a profession.
Yeah. Speaking of quality assurance, that's the argument people make for using robots, and hey, the precision is. What the question that's coming here is, can you tell us more about how you see the relationship of robots in the architectural industry?
Yeah, as you mentioned, there's kind of an increase in precision, fidelity, that we're talking about in terms of what can be achieved in a factory versus on site. And I think, we probably heard kind of the expressions of, if you hear a sawzall or a hammer on site, that means something didn't go well in terms of delivering the model or in the fabrication floor. But right now there's a lot of conversation around, just how far can robotic fabrication or construction impact what we're doing. And, I think on one hand, there are people that are, proponents of the on-site robotics, whether these are the crawlers that are building or, what have you. You can make the case that a drone for the photography and inspection is a type of robotics that's used by contractors every day, right? That's something that I think, we could, as a profession in practice, we could take additional steps to kind of interrogate, what are the limitations that we have and where do we go with it next? And I think the first step is trying to, to really properly, make use of what's available on the shop floor right now. And that kind of goes back to what we were talking about with relationships and investing our time in learning. And for as much time as we spend at the screen, on the keyboard, visiting and walking the shop floor, talking with the fabricators, inspecting the materials with our hands, looking at the tools and the processes that are available, I think these things can all inform us in ways that we can make better use of automation, design for manufacture, before it ever gets to the idea of, robots on site. I think that, we're not fully tapping into what's available with design for manufacturing at the moment. And that's not to say that we can't leap and work on them both at the same time, but that's something that's of interest to me is, tying this back to the context of, the world we're living in and things that are issues. I'm out here in the Bay Area, and one of the problems that we have here in much of California is a lack of housing. It's not even really affordable housing in the sense that we probably grew up with. It's just, there's a lack of housing, right? Of housing of really of many ranges, but definitely for people that are of middle working class. And when you look at that, there's a myriad of reasons why why we're seeing this, but design for manufacture and thinking about automation, that's a way that we can think about speed to market. If we're thinking about digital delivery, increasing the speed through the permitting process, anything that we can do to bring computation, digital delivery, design automation, to the forefront, those are methods that as a designer, we can use to help attack or mitigate those types of issues.
Yeah. I know, there's a huge cultural component to working this way. So as working and thinking this way, because it's not necessarily just coding. Not everyone is going to write code. Not everyone is going to, develop scripts. And with you, leading a team like the HKS Line, how have you found, or how do you impact the culture? Like how do you get people on board with this way of thinking, just at an organizational level?
Yeah. It comes back to relationships again. And, had you asked me that question at different points along, our path from when we founded Line in 2012 or 13 to now, I probably would have had different answers. But I think as I've matured, through my path, I understand that trust that we're talking about, it can sometimes be easy to overlook the relationships and the trust with people that are in your own office. And I would advocate that we always make it a point to work on building and nurturing those relationships. And in our experience, I think when we have been able to make an impact or begin to shift the culture, it's been through demonstration more so than presenting. It's one thing to preach it, it's another to demonstrate it. And I think when you demonstrate it, it's more tangible. It can be critiqued in a way that's a little less personal from someone that may be interested but maybe not quite ready to make that jump yet. So it allows those that maybe aren't within that type of computational mindset to enter at their own pace and under their own terms. And I can't say that I've cracked the code or that I'm always successful with that, of course, but I think that that's something that I have learned to be more mindful of, and that's kind of the approach that I lean toward.
And with you being a professor, I don't know, are you still studio? I know you mentioned with Texas.
Yeah, our line studio will continue to have an advanced graduate studio with UTA. We're not doing a line studio this fall. However, we are working with our research group. HKS has a third-party research group called Cadre that's a nonprofit that has collaborated with the University of Texas system, looking at some housing for aging. So thinking about accessory dwelling units for the aging population. And so this can be a research problem, a fabrication problem, and a design problem. So we're going to be involved in that this semester, but continue to stay tapped in at the university level.
Gotcha. With the level of involvement with academia, what kind of advice will you give students just in light of writing your software? Like, what should they be learning? Because there's so much right now that it seems like, where do I start? I don't know.
Yeah.
Is academia even doing a great job right now of producing viable employees? What do you think?
Yeah, and I've heard that question. I think so. So I'll start off with just some quick practical advice. It's not like there's not a lot of philosophical bent to this, but I will say that in terms of early conceptual work, Rhino is a platform that we use in the studio a lot. And the benefit of Rhino is, from the experience of most people that I've taught or that use it, in a professional setting, it's really doesn't take much more to learn than something like SketchUp. However, the opportunities for the ecosystem of plugins and the ways that you can begin to run simulations, drive fabrication, have interoperability, these are things that I think Rhino really offers. And so that's kind of my practical advice. That's a good platform to focus on. Going beyond that and thinking maybe a little deeper around that, I heard something talking with Michel Rochkin, architect from Mexico City, one time, and he mentioned that. Try not to misquote him here, but try to kind of summarize it. When he hires anyone, even right out of school, he says, "I don't expect you to have the answer, but I expect you to have an opinion." And so if you're thinking about what can I bring so that I can have an opinion, so that I can make an impact, there's different things that you can do. And one of those is you can kind of think about, we've heard of T-shaped people, right? Kind of this study about having a broad skill set, but going deep on one thing, and I have maybe it's Y-shaped people because we're always striving, whatever you want to look at for that letter, right? But if you can work on computation and taking an aspect that's of interest to you, it could be some type of environmental simulation, daylight, solar, it could be looking at life cycle analysis. Think about the problems that you're seeing in the world and think about, how can computation be a tool that can help me towards solving those. You don't have to be the best at anything. You don't have to know all of these suites of software, but if you can come out of school and you can do one thing at a office professional level, like you graduate, you get in an office, and if you say, I can run a solar simulation and give you, some SDA analysis, you're going to get to the table. You're going to be there working with the team based on what you can bring day one. And that's why having something that's deep enough to get you to the table, that then gives you the platform for your opinion. And more importantly, it puts you elbow to elbow with your mentors and the people that you can hear and listen to and learn from. And so I would say, if you want that impact, that's what I always encourage students. Think about something that can differentiate you. That day one, we know you're not an architect with 10 years of experience. We're not going to expect you to lead a project, but you can do this really well. You're going to be in demand, and you're going to get to the table, and you're going to have that opinion.
I'll say for a final question, because we have 4 minutes left on the clock here. And not to put you on the spot, but what are you reading now, or what is a book you feel everyone should read?
That's so I'm opening up my Audible app here just to see if I can make a good recommendation. I read a lot, and so I think the one that I just finished, it has really maybe nothing, but at the same time everything to do with computation. It's called Breath by James Nestor, and it's an entire book around the science of how we breathe, and how that affects everything about our health and our well-being. It's a little out there in some ways, but my good friend and the chief technology officer of HKS, Corey Brugger, recommended it to me, and I just finished it, and it was phenomenal. So I definitely would recommend that one. Other ones recently that I think have been fantastic. Loon Shots by Safi Bakal is a great one to kind of think about innovation. That's a great book, and I have this up on my list because I was just referencing it for some things that I was doing recently, kind of thinking about some strategy. And then there's a great 3-part series of books by Yuval Harari called Sapiens. And if you haven't read these are like the condensed version of the history of the world, all of it, and they are amazing. So
yeah, it's like Homo Deus.
Yes, yeah.
There's one more I'm missing, but yes, there's
yeah.
Well, Heath, thank you so much for joining us today. And the recording of this discussion you can find on our YouTube channel. So feel free to check it out if you want to go back and hear all the amazing things Heath has said in this discussion section. That's it for today, and Heath, we just really appreciate you showing up today.
I appreciate you and the opportunity to talk with you. There's some good questions, some questions that I'm jotting down that I'm going to go back and try to dig into some more. And I just want to say thank you, express my gratitude again. And this is an amazing program that you guys are putting together. And I think this is what we need. We need more of this in the profession, the industry, more of this type of conversation. And thank you guys for doing what you do.
Thank you. All right. Have a good night.